Okay, class, today we're going to be talking about chapter 12.6. This is surface area of a sphere and volume of a sphere. Now, I'm going to zoom out a little bit. Surface area of a sphere was with this worksheet when we were dealing with pyramids and cones, and or note worksheet. So you might have to dig through that to pull that out. And then for volume, that's going to be another worksheet as well whenever we were dealing with volume of pyramids and cones. So I just want to let you know that way you can pull that out. Now we're going to go ahead and get started. For a sphere, you need to know that the surface area, the total surface area, there is no such thing as lateral surface area for a sphere. It's just total surface area. And that is 4 pi r squared. Okay, now the radius of our sphere, so if we were to just look at this circle, you know, like without it being three-dimensional, just right here, the radius would be like the radius of a circle. Well, when we add that 3D motion, we also get this to be the radius. So anytime you go from the center to the outer edge of the sphere, you have a radius. Okay. Also, our diameter would also be the same thing. So you just go from one part of the sphere to the other part of the sphere. Okay. So from one point on the surface to another point on the surface directly across, and when that goes to the center, that is our diameter. The circumference of a great circle, now the great circle is this portion right here. Now the great circle means that it has the same center as the center of our sphere. So great circle has the same center as our sphere. Okay. Now, one thing I want to point out is that all spheres are similar, just like when we were talking back in chapter 10 about theorems of a circle. All circles are similar because the only thing that differs is the side of the radius. So if you have a circle with a radius of 2 inches, then those circles are going to be congruent. But say we change the radius to be 4 inches, now our circles are still similar, but they're just not congruent. Okay? Now that's really all we need to know as far as definitions and vocab goes. So we're going to go ahead and start solving a problem here. So in this problem here, we have our radius as 3.5 inches, and we're wanting to find the total surface area of our sphere. So we know that 4 pi times the radius square, well, our radius square is 3.5. Okay, and whenever we multiply this out in our calculator, we get 153.9 inches squared. So it's not too bad. The only thing you have to remember whenever we're using the surface area volume is what line is considered our radius. And once you have that, it's not too bad. Moving on to our last problem here. We're given the diameter of our sphere. Okay, so if we wanted to draw that inside, it would be from here all the way to that edge of the sphere. So that's our diameter. So our diameter is 4.2. So half of our diameter is going to be 2.1. So our radius equals 2.1 feet. So now whenever we're solving for this problem, we're simply going to do our 4 pi 2.1 squared. And then we square our 2.1, multiply that by 4 pi, we get 55.4 feet squared. Okay, now that is it for volume, or sorry, not volume, surface area. Now we're going to move on to volume. So if you want to pull out your other note worksheet, and remember it looks like this. Okay. This formula for volume of a sphere, it's a little different than what we've been dealing with. When we were doing volume of a pyramid and a cone, it was like 1/3 times your base and your height. Well, here it's going to be 4/3. Okay, so that's the same thing as 4/3 times pi r cubed. Okay. R is our radius. It hasn't changed from our notes from surface area. So this is our radius right here, and then our diameter is this line right there. And then remember, the great circle shares the same center as the center of our sphere. So when we work this problem now, we use our new formula for volume, which is 4/3 pi r cubed. Our radius is 3.5 inches squared, so not squared, cubed. Sorry about that. And then when you put that in your calculator, you get 179.6 inches cubed. Now pay attention to our units here. Okay, so before, when we were dealing with surface area, our units were squared because we're dealing with area. Well, now that we're dealing with volume, which is three-dimensional, we have to have our units cubed. For our next problem here, we're given our diameter, 4.2. So as we remember from our earlier problem with our surface area, that our radius is 2.1. So when we solve this, 4/3 times pi, 2.1 cubed. And when we multiply this all out, we get 38.8 feet cubed. And this concludes our notes for surface area and volume of a sphere. Nice, short, and sweet, and I will see you in class.